typical geothermal system operates by using a ground loop to heat water to a moderate temperature, around 45 to 50 degrees Fahrenheit. This water is then circulated through a heat exchanger within the living space. This heat exchanger, often a hydronic fan coil or baseboard-style heater, then raises the temperature to the desired level, typically 70 to 75 degrees Fahrenheit. A heat exchanger utilizes electric resistance in the form of heat strips. These heat strips generally remain off unless the thermostat calls for additional heat. In a properly designed system, the heat strip should rarely activate when outdoor temperatures are within the expected design range for the area. The heat strips are primarily used when the geothermal system and heat exchanger cannot provide sufficient heat to meet the thermostat set point. Some utility companies offer reduced rates for energy consumption during specific hours, such as between 9 p.m. and 5 a.m., which often coincides with when heat strips are most likely to be in operation. The geothermal system only needs to raise the water temperature to 45 to 50 degrees Fahrenheit, which requires less energy than a heat strip directly heating the water to 70 to 75 degrees Fahrenheit. The fan coil or baseboard heater typically requires 1 or 2 15-amp circuits. These circuits are separate from the compressor and heat strip panel and should be protected by FP breaker size to match the heater's required ampacity, usually 15 to 20 amps. A standard geothermal system uses two 60-amp circuits, one dedicated to the compressor and the other to the heat strips. The wiring from the main panel to the geothermal unit is commonly run underground in a 2-inch conduit. This conduit typically contains two 4/0 THWM wires for each of the two panels. Each panel usually includes a 60-amp ground fault interrupter breaker. This breaker trips if it detects any imbalance between the legs of the panel. It is important to check with the geothermal installer to confirm if the panels are factory equipped with ground fault interrupter breakers. Additionally, a bonding jumper must be provided on the incoming ground, which should be a number 8 barrel wire. The two panels are typically equipped with two 60-amp breakers for the heat strips and one 40-amp breaker for the compressor. Each pair of heat strip breakers should be wired to the two 60-amp legs in each panel. The two 40-amp breakers should be wired to one of these legs and the neutral. The ground fault interrupter breaker should be wired in line with one of the conductors to each panel. The neutral should be connected together with the incoming neutral. The bonding jumper connects the ground from the incoming line, the ground connection on the geothermal panels, any other grounding electrodes on the property, and the neutral at the main panel. It is essential to consult with both the geothermal installer and the local authority having jurisdiction to determine the specific requirements for your area. Calculating the load for a geothermal system involves considering the amperage requirements of the compressor, heat strips, and any auxiliary equipment. Firstly, determine the total amperage required for the heat strips. Secondly, determine the total amperage required for the compressor. Thirdly, account for any additional loads such as pumps, fans, and controls. These loads must be added to the total calculated load. The information provided indicates that the heat strips require two 60-amp double pole circuits. A double pole circuit is a 240-volt circuit using two hot wires, each carrying 60 amps, and a neutral wire. Therefore, each heat strip circuit has a capacity of 60 amps at 240 volts. The compressor requires one 40-amp double pole circuit. This means the compressor draws 40 amps at 240 volts. To calculate the total load, you must consider the continuous and non-continuous loads. Continuous loads are those that operate for 3 hours or more at a time. Non-continuous loads are those that operate for less than 3 hours at a time. The National Electric Code Section 220.18 states that branch circuit, feeder, and service loads shall be calculated as the sum of the continuous load plus 125% of the non-continuous load. This means that if the heat strips and compressor are expected to run continuously for 3 hours or more, the amperage should be multiplied by 1.25. If they are not expected to run continuously, their actual amperage can be used in the calculation. For example, if the heat strips are considered a continuous load, their contribution to the total load is 60 amps times 1.25, which equals 75 amps per circuit. Since there are two circuits, the total continuous load for the heat strips would be 150 amps. If the compressor is also considered a continuous load, its contribution to the total load is 40 amps times 1.25, which equals 50 amps. The total calculated load for the heat strips and compressor, assuming both are continuous loads, would be 150 amps plus 50 amps, which equals 200 amps. This is the simplified calculation. A complete load calculation must also include any other loads associated with the geothermal system, such as pumps, fans, and controls. These loads should be added to the calculated load for the heat strips and compressor to determine the total load for the system. Furthermore, it is important to consult with the local authority having jurisdiction and the geothermal installer to ensure that the load calculation complies with all applicable codes and regulations. The National Electrical Code provides guidelines for load calculations in Article 220. These guidelines should be followed to ensure that the electrical system is properly sized to handle the load of the geothermal system. In addition to the load calculation, it is also important to consider the voltage drop in the wiring. Voltage drop occurs when the voltage at the end of a conductor is less than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends limiting voltage drop to no more than 3% for feeders and 5% for branch circuits. To minimize voltage drop, it is important to use conductors of the appropriate size. The size of the conductor depends on the amperage it will carry and the length of the run. The National Electrical Code Table 310.16 provides ampacity ratings for conductors based on the size and insulation type. It is important to select a conductor size that has an ampacity rating greater than or equal to the calculated load. In addition to conductor size, it is also important to consider the type of insulation. The insulation type affects the ampacity of the conductor. The National Electrical Code Table 310.16 provides ampacity ratings for different insulation types. It is important to select an insulation type that is suitable for the application. The location of the geothermal unit also affects the wiring requirements. If the geothermal unit is located outdoors, the wiring must be suitable for outdoor use. This means that the wiring must be resistant to moisture, sunlight, and temperature extremes. The National Electrical Code Article 310 provides requirements for wiring in wet, damp, and dry locations. It is important to select wiring that is suitable for the location. Grounding is also an important consideration for geothermal systems. Grounding is the process of connecting the electrical system to the earth. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock and fire hazards. The National Electrical Code Article 250 provides requirements for grounding electrical systems. It is important to follow these requirements to ensure that the geothermal system is properly grounded. Bonding is another important consideration for geothermal systems. Bonding is the process of connecting different metal parts of the electrical system together. Bonding helps to create a low impedance path for fault current to flow back to the source, which helps to protect against electrical shock and fire hazards. The National Electrical Code Article 250 provides requirements for bonding electrical systems. It is important to follow these requirements to ensure that the geothermal system is properly bonded. Overcurrent protection is also an important consideration for geothermal systems. Overcurrent protection is the process of protecting electrical circuits from excessive current. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current if it exceeds a certain level. The National Electrical Code Article 240 provides requirements for overcurrent protection. It is important to follow these requirements to ensure that the geothermal system is properly protected from overcurrents. Surge protection is another important consideration for geothermal systems. Surge protection is the process of protecting electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, utility switching, and other events. Surge protection devices, such as surge suppressors, are designed to divert voltage surges away from sensitive electrical equipment. The National Electrical Code Article 280 provides requirements for surge protection. It is important to consider surge protection for geothermal systems, especially in areas that are prone to lightning strikes. Disconnecting means are also important for geothermal systems. A disconnecting means is a device that can be used to disconnect the electrical power to the geothermal system. The National Electrical Code requires that a disconnecting means be provided within sight of the geothermal system. This allows service personnel to safely disconnect the power to the system before performing maintenance or repairs. Labeling is also important for geothermal systems. The National Electrical Code requires that electrical equipment be labeled with its voltage, amperage, and other important information. This helps to ensure that the equipment is properly installed and maintained. The labeling should be clear, concise, and easy to understand. The geothermal installer should provide the necessary labeling for the system. Permits and inspections are also required for geothermal systems. Most jurisdictions require that a permit be obtained before installing a geothermal system. The permit process ensures that the installation complies with all applicable codes and regulations. The installation will also be inspected by a qualified inspector to ensure that it is safe and meets all requirements. The geothermal installer should be familiar with the permit and inspection requirements in your area. Coordination with other trades is also important for geothermal systems. The electrical work must be coordinated with the other trades involved in the installation, such as the plumbing and HVAC contractors. This helps to ensure that the installation is properly integrated and that there are no conflicts between the different trades. The geothermal installer should be responsible for coordinating the work of the different trades. Safety is always the most important consideration when working with electricity. It is important to follow all safety precautions to protect yourself from electrical shock and other hazards. Always disconnect the power before working on any electrical equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to perform electrical work, hire a licensed electrician. The National Electrical Code is a comprehensive set of standards for electrical installations. It is important to be familiar with the National Electrical Code if you are involved in the installation or maintenance of electrical systems. The National Electrical Code is updated every 3 years. You can purchase a copy of the National Electrical Code from the National Fire Protection Association. Local codes and regulations may also apply to geothermal systems. It is important to check with the local authority having jurisdiction to determine the specific requirements for your area. These codes and regulations may cover a variety of topics, such as wiring methods, grounding, and overcurrent protection. It is important to comply with all applicable codes and regulations to ensure that the geothermal system is safe and meets all requirements. The information provided is for general guidance only. It is not intended to be a substitute for professional advice. Always consult with a qualified electrician or geothermal installer before performing any electrical work on a geothermal system. They can assess your specific situation and provide you with the advice and guidance you need to ensure that the installation is safe and complies with all applicable codes and regulations. Remember to always prioritize safety when working with electricity.